Yeah, 5 more to go. Before we continue, let's stop, pause, and just recap a couple things. When you have an ionic compound or an acid or basically something in the form, a compound in the form of AB plus, let's go with XY as reactants, and oftentimes these are in aqueous solution, right? And then especially when you notice that the compounds are have cations and anions, ionic compounds. You're just going to switch the cations and get the products. Sorry, cations are written first. All right, and then use solubility rules to determine which one of these will precipitate or become, sometimes it's water, which is then a liquid, or sometimes they'll be gases. There aren't as many of those examples though. All right, so all these are going to be in that kind of format. Just look out for that. All right, let's do problem A. Sulfuric acid, the formula is given there for you. So that's going to be H2SO4, and these are all in solution, and that's going to mix with barium chloride. So to get the formulas, always use the charges. Barium is a alkaline earth metal, and chlorine is a halogen. So you want to crisscross those charges to get BaCl2, and you're going to write AQ for um, to indicate that that's soluble. All right, let's switch these cations. Hydrogen X has a cation in this case, so that's going to be HCl. That's going to be a hydrochloric acid, by the way, which is soluble. And then sulfates are generally soluble, but barium is those larger alkaline earth metals are exceptions. They're both 2 charges, so 2 negative and 2 positive, they're going to cancel out. So the formula unit is just going to be BaSO4. That's your precipitate. So I have this solubility rules up here. Sulfates are generally soluble, but these larger alkaline earth metals are exceptions, which means they are insoluble. All right, that's the precipitate there. Okay, so we're going to balance this. Just pick a different shade. There's 2 hydrogens on the left, only 1 on the right. So let's multiply, add a coefficient of 2 there. That might do it, because now the chlorines are balanced. Bariums are balanced, and yep, that's going to do it. So 1, 1, 1, 1, 2, 1. All right, so now we're going to write all of these aqueous, these soluble compounds dissociated. All right, let's move these in the quantities into the coefficient. So it's going to be 2 protons. All right, that's the charge, and AQ. And then sulfate is SO4 with a 2 minus charge, AQ, plus a barium cation, which is group 2. Cations are 2 positive, AQ, and bring that 2 to the front, because otherwise you're saying it's a molecule, and it's not. These are all freely floating around ions, so we want to separate them. Whoops. And so that's going to lead to, I'm going to run out of space. I'm going to just stagger it down here, otherwise I would keep going. All right, so 2 protons on the right side, on the product side, dissolved in water, soluble, and then don't forget to distribute that also to the chlorine. So there's 2 moles of chloride ions, you could say, AQ. Right, and then plus, finally, we have our precipitate, which we'll just copy the way it is, because that's insoluble. All right, we're going to cross out the spectators. Those are the ones that appear on both sides of the equation, and rewrite what is left for our final net ionic equation. All right, so that's going to be the sulfate ions reacting with the barium cations in solution to form barium sulfate precipitate. There's your balanced net ionic equation. The atoms are balanced and the charges are also balanced.